Math 3, Unit 3, Section F. This goes along with Worksheet 6. So we're going to be talking about long division and synthetic division. Okay, so to start this out, what I want you to do, and do not solve the problem, is I want you to go 5 long division goes into 370. Okay, but do not work that out. Okay, and then over here, same thing, we're going to write x minus 1 divides into x squared plus 6x minus 7. Okay, so doing this problem over here is going to help us with the long division of a polynomial. Okay, so when you're doing long division, what do you do first? So going to this problem right here. If you were dividing there, what would you do first? So yeah, 5 doesn't go into 3. So you're like, how many 5s are in 37? Right? 7. Okay, and then what do you do? No. You multiply. 7 times 5 is? Okay, we're going to stop there for just a minute. So we're going to end up doing the same thing over here. You are always looking at this first term, just like how we looked over here at the first term and this first term. And you are trying to decide x times what makes x squared? X, right? X times x makes x squared. And so since it's just a plain x, you're going to line it up with the plain x. See how just like here I lined up the 7 in the second spot? Same idea, okay? Just like I did 7 times 5 is 35. Over here, we're going to have to go x times x, which is x squared, and x times negative 1 is negative 1x. Okay, and the reason why is because since there's 2 terms here, I have to multiply this by both of those terms. Are we okay with that? Hold on 1 second here. We ended up getting more money, so I counted it, but then I didn't count it with the more money.
Thank you.
Find out. Okay. All right. Okay, back to math. So, on this next one over here, you guys talked about how once we multiplied by the 35, what did we do next? We subtracted, okay? And so 37 minus 35 is 2. Okay, stop there again. So guess what we're going to do over here? We're going to subtract. But when you're subtracting, we're subtracting with 2 different numbers. And so when you subtract, this one becomes a minus, and then this one is going to end up becoming a plus. What should happen is that this first term cancels out, and it does. 6 plus 1 is what? 7. So I have 7x. Okay, going back over here. What is your next step when you're doing long division here? Bring down the 0. Guess what I'm going to do over on the other problem? Bring down minus 7. Okay, and then what do? I say 5 times what equals 20, right? 5 times what is 20? 4. And we go 5 times 4, which is 20. Okay, I'm going to stop there for just a minute. Yes? Why is it plus 1x? Okay, so going backwards real quick. X times x was x squared. X times negative 1 was negative 1x. But when we subtract, this becomes a minus and this becomes a plus. Because what you're basically doing is, okay, so let me just go backwards. This was originally a positive and this was a minus, right? Mm-hmm. You'll always switch the signs because what I'm doing is I'm subtracting that whole thing. Does that make sense? So you have to end up changing both of the signs. And so this becomes a minus and this becomes a plus. And when that becomes a minus, it cancels it out. which is what's supposed to happen. If it was a plus, then you'd have 2x squared and it didn't really do anything. Okay? All right, are we good here? Yes? Okay, so now, I feel like half of you are not paying attention. Okay, just like we did over here where we were saying 5 times what is 20, again, we're looking at x, and you're always looking at the first part, so 7x. So x times what is 7x? 7, and specifically a positive 7. So if it's a positive 7, we write plus 7. If it was a negative 7, Zach, we'd put minus 7, okay? So since it's a plus 7, we're putting plus 7. So now we have to, just like we did here and went 5 times 4 is 20, I now have to go 7 times x, which is 7x, and 7 times negative 1 is negative 7. Now just like over here, what do I end up doing with the 20 I multiplied by? I subtract, and there's nothing left over. So again, what do I have to do over here? Subtract. And when I subtract, I end up changing both of the signs, right? So this becomes a minus, this becomes a plus, and these both cancel out, and there's 0 left over. Okay, so back here up at the top, it says when you have a remainder of 0, the term was a factor. So see how I have a remainder of 0? X minus 1 is a factor of this problem. It does divide in evenly. So is x minus 1 a factor? Yes. If your remainder is anything other than 0, then the term was not a factor. Okay? So we're going to actually skip down here to C for a minute, and we're going to try practicing another long division problem. Okay? And then we'll go over to synthetic division. Okay, so again, long division, I'm going to write x minus 2 divides into, and there's one thing that you always want to be careful of, and that is that this needs to be in descending order. So you see how like 3 is an exponent, 2 is an exponent, 1's an exponent. If you were missing any power, you would put like a 0x squared in there if it wasn't there, okay? You won't see that too often, but just so you know. So I'm writing this out. Okay, and so what do we do first? We look at which terms? The first 2 terms. Good. So x times what would make x to the 3rd power? X squared. And so I'm going to line that up with the x squared term. Okay? And you'll notice then I'll probably end up having 3 more terms here. It kind of lets you know how far you have to go. Okay? So now what do? Multiply. X squared times x is x to the 3rd, and x squared times negative 2 is negative 2x squared. Okay, and next I do what? Subtract, and when I subtract, I'm going to, good, so we get a minus and a plus. These cancel. 5 plus 2 makes Or anybody have questions up to this point or need something explained? Oh, it's here. You just can't see it. I just wrote it wrong. Are we good now? Okay. All right, what's next? Very good. Bring down the minus 21x. And now I'm going to look at x and 7x squared. Correct? Okay, so x times what would make 7x squared? A positive 7x. So we go 7x times x, which is 7x squared, good. And 7x times negative 2 is negative 14x, but then what happens? So this becomes a minus, and this one becomes a positive. These cancel. Negative 21x and 14x makes negative 7x. Then we bring down the minus 9. Okay, so now we're looking at x and negative 7x. So x times what would make negative 7x? Negative 7. We multiply negative 7 times x is negative 7x. Negative 7 times negative 2 makes a positive 14. But then I need to do what? Okay, were you okay with getting a negative 7x here? And then all I did was bring down the next number, which is negative 9. You're always looking at that first term and this, what you're dividing by. So negative 7x times what, or x times what makes negative 7x? So you're looking x times what will make negative 7x? A negative 7. So that's why in red right here I wrote a minus 7. And then we take negative 7 times x, which made the negative 7x. And then negative 7 times negative 2 makes a positive 14. Okay? But then I need to do what? Change my signs because I'm subtracting. So this becomes a plus and this becomes a minus. Now these cancel out and I have negative 9 and negative 14, which makes negative 22. So this has a remainder of negative 22. The way you write that is negative 22 over whatever you're dividing by. And what am I dividing by? X minus 2. So this would be my answer here. Okay, questions? 23, you mean? Negative 23? Yes, good. Candy for both you and Zach. Okay. All right, negative 23. Jen, I saw your hand raised. Did you have a question still? No. Anthony.
So we just combine negative 23
No. This was negative 9 and negative 14 made negative 23. And then you just write, no, this is like, it's like this and this. Like negative 23 over x minus 2 is separate from this. Okay, but it's all part of the answer. It's just like if I had a remainder of 2, you would put 74 and 2/5. Because you're dividing. Okay, let's pretend like this was a 1. Okay, 371. So when I brought this down, this was a 1. It still goes in 4 times, which is 20, but when I subtract, there's 1 left over. You would write this, you could do like a decimal or whatever, or you could have written this as 74 and 1/5 because there's 1 out of 5 left over.
Oh, you just put it over.
So my remainder, I'm just putting it over whatever I was dividing by. Is that better?
Just so it's basically 2 answers.
Well, it's all one answer, but they're 2 separate pieces in a way. They're not together. They're okay. Just like this is kind of separate from the 74, right? Okay. All right, so was x minus 2 a factor, yes or no? No. And how do we know? No, yeah, because there was a remainder, or it wasn't 0. Okay, so now we're going to go look at synthetic division. Synthetic division is actually way easier than long division. Okay? But you should know how to do both. And so we're going to go back up here to B. Okay? First thing is we're going to make this little box. And this is going to be the number that we're dividing by. When you are getting the number that goes in this little box, you are always going to take the opposite of whatever is here. So if I were, just like anytime, if I were to go x minus 1 equals 0, I'd end up getting x equals 1. So 1 is going to be that number that goes into that box. Please focus. You guys have never seen this before, and a lot of you are talking and not paying attention. Okay, so again, this 1 came from me taking x minus 1, setting it equal to 0, and getting a positive 1. Okay, now, the next thing we're going to do is we are just going to write the coefficients of each term. Okay, so I'm going to write here coefficients, or coefficient of each term. Now remember how I said to make sure it's in descending order? And so like if you were missing like a plain x, we'd end up putting a 0 in, okay? So what's the coefficient of the x squared term? 1. And we're going to do a little space. And what's the coefficient of the x term? 6. And then our last number is just -7. We're going to make a line here, and we're going to end up having numbers in these spots. So it's like you need a spot for a number. Okay? And this will get practice, and it'll get easier. You always bring down the first number. So I'm just going to write here, bring down the first number. So in this case, I'm going to bring down 1. Okay, the next thing you do is that you take this number and you multiply it by the number in the box and put it under the next number. So I mean that you're taking this number and you're multiplying it to that number. Okay? So what is 1 times 1? 1. So we put that under the 6. Okay? And then you always, and I'm just going to put this right here, add down. So what is 6 plus 1? 7. And then we do the same thing again. So that means I'm going to go 7 times 1 is what? 7. And we add down and I get 0. Okay. Now, when you are writing out your answer, okay, so I'm just going to put here, write out starting with 1 less exponent. So what I mean by that, this right here, this is my answer. This number right here also, here's another little note here. Hopefully you'll be able to read your notes later. That is the remainder. So there's no remainder on this one because the number is 0. So what is 1 less than x squared? That would just be x. So this becomes x. And then once I take 1 less than x to the first, there's no x, right? So this will be x plus 7 is my answer. Now, if you look at this problem right here and this problem right here, they are the same. The answer I got for this problem over here was x plus 7. The answer I got for this problem over here was x plus 7. So we got the same answer either way, and this may seem more complicated right now, but it'll be a lot easier once we go through it a couple more times. So you'll get the same answer either way. So in this case, was x minus 1 a factor? Yes, and the reason is because my remainder was 0. Okay, so let's do another synthetic division problem without all the notes. Oh, questions first. Yes. So see this answer right here? This is really 1x, but I just don't write the 1, and then plus 7. And so this exponent started with, in your problem originally, is x squared. When you're dividing out, you just go 1 less of the exponent. So instead of x squared, I have x to the first, but we just don't write the 1. Okay, other questions? Yes. The 6. Well, it ended up reducing. Just like there's no 6 in this answer either. We had to add 6 plus 1 and got that 7, right? The same thing happened here. We added 6 plus 1 and got 7. Okay, because when you're dividing, you don't end up with the same thing that you started with, right? It's always going to change. Just like here when I divided. It changed. Okay, let's do another one, and I can still go back and answer questions. Sometimes doing another example makes it all come together. Okay, so what number will go in my little box? -2. Now, this says x to the 4th, x to the 3rd. Do you notice how it's missing an x squared? So if you were to actually write this, I think you should rewrite it as x to the 4th plus 3x to the 3rd plus 0x squared, because you want it to have one of each power, okay? Plus 6x minus 2. So that's what I mean by if you're ever missing something in your descending order, you want to add a 0 in for that, okay? Because if you add 0 to anything, it's like you're adding nothing, right? Because 1 plus 0 is still 1. Okay, so when we write this out, we have to write our coefficients now. So starting with our first term, we're going to write a 1 and then 3, 0, 6, -2. Hey.
There's a cabinet
Okay, so what are we going to do with that first term? Bring it down, and then once you bring it down, what happens? You multiply it. Kind of go through and see if you guys get it. Hopefully you have a new pencil, that way if you mess up. Okay, you guys ready for me to go through it? Okay, and then if you want to too, this last number right here, I do another box around it to remind me that that's my remainder number. Okay? So when we bring it down, we have 1. 1 times -2 is -2. 3 minus 2 is 1. 1 times -2 is, and 0 minus 2 is -2. -2 times -2 is 4, and 6 plus 4 is 10. 10 times -2 is -22. And when you add those together, it makes -22. Okay. So how would I end up writing this answer? We start with one less exponent, so that means it's going to be x to the 3rd plus x squared minus 2x plus 10. And when you write your remainder, it's -22 over what? Good. Is that one a factor, yes or no? No. Okay, questions? Yes.
I just don't get how you said the last equation, like the answer, I guess.
The part in red or just the answer?
Yeah, like
Okay, so once you have all these numbers here, you go to your original problem. Do you see how that has an exponent of 4? You just go one less. And the reason why you're going one less is because you're dividing out an x. So that means each of these x's will go down by 1. And so you get x to the, so whatever this number is, that number is actually in front. So it's going to be 1x to the 3rd since it was originally x to the 4th. And then this one is 1x squared. You go down with each term. And then -2x and plus 10. Is that better?
yeah.
Okay. All right. Okay, E and F. Are you guys ready? So let's do E together, and then I might have you try F on your own. So first of all, if you notice here, it's not asking us to divide, it's asking us to factor. So we're going to end up writing out all of the factors, okay? They're telling you that one of the factors is x minus 5. And so what we're going to do is use synthetic division to see what our answer is once I divide out x minus 5, okay, once I take that factor out. So if I'm using synthetic division, okay, also look, this goes 3, 2, 1, 0, so I don't have to add in any zeros, okay? What would be in my little box up here? 5. Okay, then from there, which numbers do I write? 1, negative 1, negative 17, negative 15. Now, they have told me that x minus 5 is a factor. I should get a remainder of 0 over here. If I don't, then I probably did something wrong. Okay? So, bring down our 1. Next, we multiply. 1 times 5 is 5. Negative 1 and 5 is 4. 4 times 5 is 20. Negative 17 and 20 is 3. 3 times 5 is 15. Negative 15 and 15 is 0. So it worked out. When I write this out, how do I write it? X squared plus 3. And then what else? What is another factor? It's x minus 5, okay? Because they told us x minus 5, that's how I divided this out to get this answer. But x minus 5 is still one of my factors, okay? So when we're factoring it, we're not dividing, okay? We have to write out all the factors. Can this be factored further? Does anything add to be 4 and multiply to be 3? Yeah, 3 and 1. So I end up with x plus 3 times x plus 1 times x minus 5. Oh, and I should write f of x equals that. Okay, so those are all my factors. And this should kind of look familiar because obviously, well, I don't know if it's obvious, but we're going to end up graphing these, right? We're going to end up factoring and being able to graph just like we've done on all these other problems. Okay, can you guys try f on your own? See if you can factor this all the way. I'm going to come around and check your answers.
Just you? Release the back over. Alternative. Right now, this is unacceptable. If you choose to not go there and get notes, you can get out of this. But this is ridiculous. I am not going to what's happening. Look, when you just like this, you can factor that for okay, so what multiplies to be negative 4 and adds to 2. Perfect. Good job. Okay, so you didn't get a 0, so that means you find that stuff. Okay. So that's right. That's right.
Okay, I wasn't able to kind of make around to everybody. This should be your final answer right here. So you should have ended up with x minus 2 squared and x plus 3. Okay? So, if we're using synthetic division, okay, we have a negative 3 here in this box. Okay? When we go out, we have 1, negative 1, negative 8, and 12. Okay, we bring this down, we get 1. 1 times negative 3 is negative 3. Negative 1 and negative 3 is negative 4. Negative 4 times negative 3 is positive 12. 12 and negative 8 makes 4. 4 times negative 3 is negative 12, and we have 0 left over. Okay, when you write this answer, this would be written as x squared minus 4x plus 4, and we can't forget that I just divided by x plus 3, or factored out an x plus 3. This then, we're looking for something that adds to be negative 4, and that multiplies to be a positive 4. It's negative 2 and negative 2. Since we know they're both negative 2's, you could write that as x minus 2 squared. Okay, we wouldn't end up having two separate ones. Or you could do the step where you write them both out, but then notice that they're the same and you write them as a square. Because what do we know when we're graphing when you have a square? It bounces. Okay, and so having a square is important to know when you're graphing. Okay, do we have any questions here? Okay, so now we're moving on to the graphing part. Okay, we have two problems here. Before you start though, I would like you to do a couple things. And that is, state what your degree is. So in this case, I'm going to kind of go down here to the bottom where my graph is. What degree is this problem? 3. And we know the degree is a 3 because of the highest exponent. What is my leading coefficient? Is that positive or negative? Positive. So, since my leading coefficient is positive, that means my right in behavior is positive infinity. Since it's an odd degree, that means my left in behavior will be negative infinity. So we're going to go ahead and just mark those there so we're ready to go once we get our x-intercepts and y-intercepts. Okay, so going back, they're telling you that 3 is going to factor. Now, that 3, what does that actually mean as a factor if I were writing it with an x? It actually means x minus 3. Because if it equals 3, it would actually mean x minus 3, right? Okay, so we're going to use synthetic division. We're going to put 3 in our little box and double check that it goes down in order with our exponents, and it does go 3, 2, 1, and so we don't have to worry about putting any zeros in. And so going across, what numbers will I write? 2, 5, negative 28, and negative 15. And because they're telling me that 3 works, I should end up with a remainder of 0 here. Okay, and if I don't, then I know I messed up somewhere. So we bring down the 2. 3 times 2 is 6. 5 plus 6 is 11. 11 times 3 is 33. Negative 28 and 33 is 5. 5 times 3 is 15, and negative 15 and 15 is 0. Okay, when I write this out, I have 2x to what power? Squared, plus 11x, plus 5, and then my other parenthesis is x minus 3. Do you guys remember how to factor this, what we do? Very good. You start with going 2 times 5, which is 10. So that means that my multiplying number is 10 and my adding number is 11, right? But we still write this, we're going to write with 4 terms. You'd write this as 2x squared, and then what two numbers work? So that's 10x and a 1x, or just x, and then I saw plus 5. Do you guys remember this? Okay, and then we have to factor by grouping. So all I did was change this 11x to be 10x and 1x, right? That's all I did. And so in my first group here, what's my GCF? 2x, and I'm left with x plus 5. What would I take out of this second group? A 1. Okay, a positive 1, and I'm left with x plus 5. So when I end up factoring that and I take out my GCF now, which is x plus 5, I'm left with what? Good. 2x plus 1. And then I still need to bring down my x minus 3. So I'm going to stop there for a minute. Are there questions? Who knows what I do now? Good. So this will be x equals what? Negative 5. And so I'm going to go 1, 2, 3, 4, 5. Make a point. Will that be a bounce or a pass through? Good. Okay, next one. Now, if you can't, yes. Why? No, because this is factoring by grouping. This is now your GCF was x plus 5, and you're just left with 2x plus 1 when you divide it out. Yeah, it always just stays as 1, okay, when you're doing grouping. Okay, if you're not sure what this equals when you set it equal to 0, just go to the side and put 2x plus 1 equals 0. You would subtract 1 to both sides. 2x equals negative 1, and then you would divide by 2. And so in this case, x equals negative 1/2. Negative 1/2 is in between 0 and negative 1. So I'm just going to put a point there in the middle. Is that going to be a bounce or a pass through? Good, pass through. And again, how do we know it's passing through? Yeah, the exponent, each of these are odd exponents, right? If it's an even exponent, then it's a bounce. Okay, x minus 3 will be x equals 3. So at 3, that is also going to be a what? Pass through. Now you need to look. Is your y-intercept already put on this graph? No, so we have to find the y-intercept. But if you go back to the original problem, the y-intercept is super easy to find. Because if you plug in 0 here, it's going to make this 0, it's going to make this 0, it's going to make this 0, and all I'm left with is what? Negative 15. So my y-intercept is negative 15. So on my graph, I go down, I make a point, and I call that negative 15. Okay, so now all you have to do is do our graph. Okay, so it's starting down, it's passing through. It turns around, it passes through again. Hopefully you can draw better than me. It goes down, it touches the negative 15, it turns around, and it passes through again. And did it all work out? Yes. Questions? Okay. H. H is a little easier. I was going to have you do it on your own, but we don't have time for that. So we're going to do it together. What number is going to go in my little box for synthetic division? Negative 5. This goes 3, 2, 1. We're good in descending order. So my coefficients are 1, 9, 24, 20. What do I always do with that first number? Bring it down. I have a 1. 1 times negative 5 is negative 5. 9 minus 5 is 4. Now we go 4 times negative 5, which is negative 20. 24 minus 20 is 4. 4 times negative 5 is negative 20, and my remainder is 0. When I write this out, it will be x squared plus 4x plus 4, and then my other parenthesis will be x what? Very good, because it's always going to be the opposite of whatever that was. So we have x plus 5. What does this factor to be? What adds to b4 and multiplies to b4? Okay, so that means I have x plus 2 what? Squared. Good. And then x plus 5. I forgot to at the beginning, so we're going to go back and do it. What degree was this? 3. What was my leading coefficient? Positive. So that means my right end behavior would be positive infinity, and my left end behavior will be negative infinity. Okay? So when I go through here on the x plus 2, that's going to be x equals negative 2, and it's a bounce. So at negative 2, there's a bounce. We have x equals negative 5, and that's a passing through. Okay? My y-intercept on this one is going to be what? 20. So we make a point at 20, and then we draw our graph. So we're starting at negative infinity. We pass through. When I get to the bounce, I touch it, and it goes right back up. It goes through 20, and it keeps going up to positive infinity. Any questions?